Hey y'all, Miss Sorensen here with video 13, Law of Cosines, and we've got some word problems fresh out of the bakery for you. We've got 4 problems to do, and they're really not too bad. We just have to make sure we're labeling our triangles correctly and solving them. All right, let's read this. When designing a kitchen, the stove, sink, and refrigerator form the work triangle. By design, the 3 parts of the work triangle must be no less than 3 feet apart and no more than 7 feet apart. If in a current kitchen, the sink is 3.6 feet away from the stove, well, let's go ahead and draw that. So we've got the sink is 3.6 feet away from the stove. So we've got sink. And we've got stove. We'll go stove here. The sink is 3.6 feet away from the stove and 5.7 feet away from the refrigerator. So we've got the sink is 5.7 feet, 5.7, and I call this the fridge. Okay, we've got a triangle here, obviously. If the sink forms a 120-degree angle with the stove and the refrigerator, so that here would be, and this is really not to scale, sorry about that, but we've got a 120-degree angle between the sink forming with the stove and the fridge. We have to figure out whether mathematically we have a good work triangle here, meaning is this side right here gonna fit this criterion that it has to be no less than 3 feet apart and no more than 7 feet apart. Okay, so let's go ahead and solve for that side. And to do that, I think it's really helpful to label our triangles with A, B, and C. Otherwise, I get kind of confused. So let's call the sink A, let's call the stove B, and let's call the fridge C. So that would give me side A, side B, and side C. And so because I'm looking for this right here, I'm going to choose the formula to find A. All right, so that's going to be A squared is equal to b squared plus c squared minus 2bc cosine A. So let's just go ahead and plug right into that. That's going to give me a squared equals 5.7 squared plus 3.6 squared minus 2, 5.7, 3.6, and then cosine of our angle of 120. All right, I do all that into my calculator and I get a squared is equal to a 65.97. Square root that. Do your best to keep the whole thing in your calculator and I get roughly 8.1222. Now, that's feet, right? Let's go back and say, does this meet the requirements? And we had to be no less than 3 feet apart and no more than 7 feet apart. Is this more than 7 feet apart? If that was 8.1 feet, yeah, it is. So does this meet the requirement? No. Does not meet requirement. And you do have to answer that. Fantastic. All right, example 2. So here we have a tornado jet and the F-16 Fighting Falcon. The Fighting Falcon. They are flying side by side in close formation. They break out of formation and the angle between their paths is 36 degrees. So if the tornado flies at 1450 miles per hour and the Falcon flies at 1350 miles per hour, how far apart are they after 2 hours? Well, first of all, we've got something like this going on where they're both kind of flying in this direction. And you don't have to necessarily have it in that direction, but it's fine. And we know that the distance between them is 36 degrees when they fly off. And let's just call this one the tornado jet, and we'll call this one the Fighting Falcon. So if they're going for 2 hours and the tornado flies at 1450 miles per hour, that means you've got 1450 twice because you're doing 1450 per hour and you've got 2 hours. So I'm simply going to do just a 1450 times 2, and that's going to give me 2,900 miles. So this is a 2,900 right here. Similarly, the Falcon flies at 1350 miles per hour. So that's going to be 1350 times 2, and that gives me what? 2700. Because it's traveling for 2 hours and it goes that much per hour. So here's our 2700. And the question says, how far apart are they? Well, that means that we're looking for this right here. So I'm going to go ahead and label my A, B, and C. It just helps me out quite a bit. I'm going to call this one my A. Whoa. I'm going to call this one my A. I'll call this my B, and I'll call this one my C. So we've got a C here, a B here, and an A. All right. So obviously I'm solving for A. I need to do my A formula. That's going to give me A squared equals B squared plus C squared minus 2bc cosine A. Plugging that all in, need a little more space here. That's going to be 2900 squared, ooh, big number, plus 2700 squared. Minus 2 times 2900 times 2700. And then we've got our cosine of 36 degrees. We do that whole thing and we do get a big number. That's roughly, 3030793.868, and we square root that number and we get A is equal to roughly 1740.91 or 1740.91 miles apart, and that's our answer. All right, example 3 here. So this problem is saying that this is something that carpenters do, and this is really true, and I've done this before as well. You can call me Carpenter Sorensen next time you see me. So to determine whether two interior walls meet at a right angle, carpenters often mark a point 3 feet from the corner on the wall, and then another point 4 feet from the corner at the same height on the other wall. So if the straight line distance between those points is exactly 5 feet, the walls are square. Prove this is true. Well, kind of hard to visualize, but I want you to imagine that this is the corner of a room. And basically what the carpenter did is said, okay, let me measure out 3 feet here and make kind of a tick mark. So they measure that that's 3 feet. And then they measure that this is 4 feet on the wall, right? This is the corner of a wall. And then they take a measuring tape and they go like this, and they see if this is 5 feet. If it is, they know it's a right angle. And you really want to verify that walls in your house or anything you're building has those right angles. So we have to prove that if this is a 5, then we do have a right angle right here. And so to do that, I'm going to label my sides as A, B, and C. And I'm going to go A, B, and C. Okay, this is a right angle, or it could be. We got to figure out if it is. So going across from that, we've got a C. Across from my B, I obviously have a B here, and then this is my A. And I'm trying to solve for angle C, and I'm trying to prove that it's 90. I'm not sure. Kind of looks like it, but we're not sure yet. So we're going to do C squared equals A squared plus B squared minus 2AB cosine C. So this is going to be 5 squared equals a 3 squared plus 4 squared minus 2 times 3 times 4 cosine C. What does this become? It becomes a 25. 3 squared plus 4 squared is also a 25. Minus, well, this right here, 2 times 3 times 4 is 24 cosine C. I got to solve for angle C, so let's get this 25 on the other side. Okay, that's going to cancel out here, and I'm left with 0 equals a negative 24 cosine C. Divide by negative 24. That cancels. 0 divided by anything is still 0, so I'm left with cosine of C equals 0. I'm going to take cosine inverse of both sides, and I get C equals cosine inverse of 0. And you should check this, but yeah, I do get that my measure of angle C is exactly 90 degrees. That's kind of cool, isn't it? All right. Okay, last one here. Same exact situation, right? We've got a carpenter But the problem is this time when the carpenter measures, they actually get 5 feet and 4 inches. And so the question is, what angles do the walls meet if the carpenter is measuring 5 feet 4 inches? Well, let's first convert this 5 feet 4 inches into a decimal. So 4 inches is actually 4 inches out of 12, which is going to give me 0.33 feet. So really when I draw this, I'm going to be left with 5.33, right? Because 4 divided by 12 gives me 0.33 feet. And I'm going to mark this as it's still going to be 4 here and still going to be 3. The carpenter still does the 3 and the 4, but unfortunately they get a 5.33. So labeling our sides CC, doesn't really matter what you do here, but I'd like to label them there. And so we're trying to solve for angle C again, so let's do that. We've got C squared equals A squared plus B squared minus 2AB and then cosine C. So plugging into that, I'm going to get a 5.33 squared equals 3 squared plus 4 squared minus 2 times 3 times 4, and that's going to be cosine of C. Okay, well, what is 5.33 squared? Well, that's roughly 28.4089 equals 3 squared plus 4 squared is still 25, like the last problem, and then this still is a 24 cosine C. Subtract 25 from both sides. Okay, that disappears here, but we are left with a 3.4089 is equal to a negative 24 cosine C. Divide by negative 24. Okay, and this cancels here, and I'm left with the cosine of C that's equal to a 3.4089 divided by negative 24. So my measure of angle C is going to be equal to the cosine inverse of all that, which is going to be 3.4089 divided by negative 24. All right, I do that in my calculator, and I get that my measure of angle C is equal to 98.17 degrees. So you can see that it kind of makes sense, right? If we were to make this side longer than 5, it definitely opens up this angle right here to be bigger than 90 degrees. And so that 98 degrees makes sense. All right, that's it for video 13. Can't wait to see you back for video 14. We're going to kind of move in a different direction from word problems and do a lot more with graphing trigonometry. Can't wait to see you back. All right, take care.